Good afternoon, good evening, wherever you're joining us from, across the planet, today is Zero Emissions Day. And so we here at Airbus thought the timing was right to spell out the roadmap of how we intend to provide a commercial zero emissions aircraft within 15 years from now. That's tomorrow in our industry. It'll be difficult, it'll be challenging, and it's highly ambitious. But today, here at Airbus, we have three leading experts who will help provide some ideas of how we're going to get there. The first is Grazia Vittadini. She's Airbus's Chief Technology Officer, and she will basically spell out the green technology solutions that we're looking at to bring a zero emissions aircraft to the skies, and why hydrogen is at the center of our focus. After that, we have Jean-Brice Dumont. He's our Executive Vice President of Engineering. He'll provide, let's say, the nuts and bolts of what a hydrogen-powered aircraft will look like. And for the first time here, we will show you just what we have in mind when we reveal three different hydrogen-powered aircraft that we're calling here at Airbus Zero E for zero emissions. And then thirdly, we then have Glenn Llewellyn. He's Vice President of Zero Emissions. And he will spell out also that while hydrogen is at the focus of our attention, Airbus can't do this alone. We need cooperation across industry, and he'll explain why. We'll be taking your questions. The panel will take your questions afterwards. Please send them to us through Twitter or through YouTube on the comments section, and of course the panel will answer those questions. That's enough from me. Straight to you, Grazia.
Thank you, Chris. It's a real pleasure to be with all of you here today. In the past months, we at Airbus have been laser focused into supporting and demonstrating solidarity with our entire ecosystem as we weather the new normal of a world having to live with COVID-19 and its repercussions for a long, long time to come. As you can imagine, this new normal is demanding answers from our industry on challenging questions, such as how can you possibly emerge from the pandemic with climate neutrality as core long-term competitiveness factor? Well, the answer is pretty straightforward. It would be impossible not to. Even well before the crisis, it had become an acknowledged and shared view that protecting climate, protecting our environment, are the key, indispensable factors upon which we have to build the future of flight. And so, at Airbus, we not only stand firm to our bold commitments to decarbonize aviation, but we accelerate our ambition with a very tangible plan to bring to market the first ever zero-emission aircraft by 2035. This means we're going to have to start selecting the specific technologies already in 2025 and, in parallel, develop concurrently and coherently a whole set of technology pathways, because in our industry, there is no single bullet solution. The timeline is ambitious, yes, but our conviction is strong. We need multiple technology pathways. We need to continue relentlessly pushing for production and uptake of sustainable aviation fuels. We need to continue leveraging on the precious learnings we gain out of our experimentation around electric flying. One particular technology pathway which we find most promising is hydrogen. And that is what brings us all here today. Let's start with the basics. So how does a hydrogen aircraft work? Well, very simply, it uses hydrogen as an energy source instead of fossil fuels. And I would like to articulate in particular on three key learnings, on three key uses we see around hydrogen. Hydrogen can be combusted directly through modified gas turbines. Hydrogen can be converted into electric energy thanks to fuel cells. And again, hydrogen combined with CO2 can be used to produce synthetic kerosene. For us, it's particularly important to combine the first two of these three elements, meaning having direct combustion of hydrogen through modified gas turbines with an embedded electric motor powered by fuel cells. To accelerate on this path, we already have in the pipeline a zero-emission demonstrator, which will be fundamental, especially to de-risk concepts such as refueling of such an aircraft and safe storage and distribution of hydrogen on board an aircraft. We aim to get the first results by 2021, and that's an extremely short time indeed to gain insights into the risk-safe storage of hydrogen on board an aircraft. Now, just think, hydrogen has the same energy levels of kerosene, so granting the same type of range and performance for an aircraft with 1/3 of the weight. Now, the catch is in the volume here, as at isoenergetic conditions, the volume of hydrogen is 4 times as much, the one of kerosene. So you can understand here how it will be fundamental to get this point right, tank design and integration onto an aircraft. One of the most typical solutions is to embed these tanks in the fuselage. And this brings us then to longer stretch fuselage, to wider diameters, with an impact, therefore, on aerodynamic performance, more drag. So it's really key to get the balance right. Another fundamental component we're going to need to de-risk and study is hydrogen cryogenics. Now, hydrogen is a gas, and it turns into liquid at minus 253 degrees Celsius. That is minus 425 degrees Fahrenheit. So it will be key to bring hydrogen to that temperature and keep it there throughout all phases of flight. As with any technology, a global transition to hydrogen will require a rethink of several elements of our quite intricate aviation ecosystem. Hydrogen is nothing you can just plug into an existing aircraft. You need to redesign an aircraft around that concept. And my colleague Jean-Brice will be giving us some insights in that sense in just a second. And just as importantly, when it comes to hydrogen, we need to spearhead a one united front, all stakeholders across industry, political arena, and research institutes. There are many, many reasons to believe in hydrogen, and our estimation is that will contribute by more than 50% along our journey to decarbonizing aviation. But our belief in what hydrogen represents is most pivotal. It is one of the most promising technology vectors to allow mobility to continue fulfilling the basic human need for mobility in better harmony with our environment, driving social and economic progress, so to enable future generations to enjoy flying just as much as we do. Thank you, and back to you, Chris.
Thanks, Grazia. Thanks very much. Jean-Brice, I think we're all very keen now for you to talk us through these new concept planes that we're putting together. Go ahead, over to you.
Thank you, Chris, and thank you, Grazia, for having set the scene. I think you've measured the technological challenge, which is between us and 2035. And 2035 is this ambitious deadline we've set to ourselves to come in service with a green aircraft, a green certified commercial aircraft. And that's really what it's about. We have named it ZEROE, you said it, Chris, ZEROE for zero emission. I think it's self-explanatory. And now we unveil today 3 concept planes, like, you know, concept cars. So you may wonder what a concept plane is. A concept plane is not a demonstrator. You heard Grazia describing the demonstrators that we have to get technologies to a level of maturity. A concept plane is not a program. We are not developing an aircraft yet. There is no exact market to enter into service with such an aircraft. But it's the aggregation of technologies that we have to put together, looking at the key parameters, one being on top of the others, safety. Aerospace has developed safer and safer aircraft over generations. And once we need to integrate hydrogen, which is more volumic, which is colder with the cryogenic conditions, affecting the architecture of the aircraft, we need to take care of safety as our paramount indicator all across the development of these concepts. Now, I'm going to unveil to you three types of concept. One which is turboprop based, one which is turbofan based, and a more revolutionary one which is a flying wing, so to say. So let's start with the turboprop that I think you will have behind me. This is an aircraft where, well, it might not look so different, but there are a few key fundamental differences. One very simple difference is the fact that there's no passenger here. The hydrogen must be stored somewhere. It's 4 times more volumic than kerosene. So naturally, we will aim at shorter ranges, shorter distances to be flown. In this case, something like 1,000 nautical miles for about 100 passengers. So that's the aircraft we would power with a turbofan, which is a turboprop, sorry, which is the equivalent to the turboprops we have today on our regional aircraft. And it is fueled by hydrogen and no longer by kerosene, which is then burnt into the turboprop. With hybridization with alternative sources of energy, like fuel cells, using the same fuel, the same hydrogen, which can bring power boost to the engines when necessary. So that's a completely different integration of energy on board that we are looking at on this aircraft, turboprop based. The second one is the turbofan. So on this one, you will see something that looks more like a classical turbofan aircraft, with again the question of storage of hydrogen. Where do we store it? So we store it in the fuselage against, and you see this aft part of the fuselage being windowless. That's where hydrogen is stored. It is then liquid carried onto the turbofans here to be burnt and to power the aircraft. So you see naturally a few features, a few revolutionary features for the aircraft that we will test in the concept aircraft together with hydrogen, and things like this chimney up there, which can be seen as a way to evacuate hydrogen gases in case there would be any kind of leak. So that's the turbofan concept aircraft. Range typically of 2,000 nautical miles or a little bit more, and the number of passengers, we would shoot for something between 120 and 200. Just to give an order of magnitude. The last one is the more revolutionary one. It combines a totally different aircraft architecture with a totally different time of fuel and energy on board. So this one is the blended wing body. You may remember the unveiling of our demonstrator Maverick at the Singapore Air Show earlier this year, which was for us an attempt to go again into this blended wing body area. Why do we go there? Because this architecture allows more space, more volume to store fuels, to store hydrogen in this case. So it gives much more freedom to much more design space to install passengers and hydrogen. So the cabin design and the hydrogen storage is obviously not fully defined. That may be seen as the step after next, but it's very interesting to study an option which is much more scalable than the other two ones. So you could imagine hydrogen being stored somewhere here and the passengers being in this area. But definitely this needs to be further tuned, and that's why we launch a concept aircraft. So all in all, 3 types of concept planes. Thrilling experiment for us. I think it's cool to be an engineer starting in aerospace today, working on these concepts that will be the aircraft of the future. And we do believe 2035 entry into service is at reach if we make things right and if the ecosystem around us evolves, as you will hear Glenn talking about in a few minutes. Chris?
Thanks very much, Jean-Brice. Just a reminder, send in your questions to Twitter and YouTube, and also for the media, the animation and video of those concept planes that Jean-Brice was talking about are now available for you to access and to get a hold of now. I will now ask Glenn to come up, if he can. So Glenn will talk us through why hydrogen is at the core of our focus, but also this is a call for action to the whole ecosystem to join us.
Sure. So what we're talking about here is really powering aviation with renewable energy. And so that means we need an energy carrier which can be created using renewable energy and then carried on board an aircraft. We know that our experience with batteries shows us that battery technology is not moving at the pace we want, and this is where hydrogen comes in. It's got several thousand times more energy per kilogram than what batteries could have today. Hydrogen on top is an energy source which is required by many industries in order for us all to meet the Paris Agreement targets. This scale and the scaling that we're going to see over the next few years is going to significantly bring the cost down. And this on top makes it very interesting for aviation. What we know is that this is going to create a massive change in the energy and aviation ecosystem. We've already started working with airlines, with energy companies, with airports, because this kind of change really requires a teaming across industry and inside the aviation industry in order to make it happen. I believe that this is the most exciting change that the aviation industry has ever seen. And I believe with our cross-industry partnerships, with public-private partnerships, this is something we can really achieve together. Thank you, Chris.
Thanks, Glenn. Would you both like to join Glenn up here at the top as we go through some of the questions? The first, Jean-Brice. It's an obvious question. Is hydrogen safe in an aircraft?
Of course, hydrogen is safe in an aircraft. Hydrogen is one of the smallest molecules you can have. It is safe to breathe. It is safe as being all around us. There is obviously a question of safety behind hydrogen storage, but if I may, aerospace has developed kerosene as a fuel, which may have some burning characteristics, and we fly very safely with kerosene since, we've been flying for decades. So yes, hydrogen is safe. That doesn't mean there is nothing to be done. Doesn't mean there is no challenge, but we are really on top of it.
Great. Grazie. It's a very news-related question for now. Why developing a zero-emissions aircraft given the current global economic context?
I think when it comes to environmental responsibility, we do not have a choice. Asking yourself whether you're going to develop a new aircraft economically or environmentally safe, well, that's a false choice. We need to bring the two topics together. And if there is something which COVID-19, what the crisis has demonstrated, is that it's dialing up the urgency for a healthy environment. So it's a false choice.
Glenn, do you believe that the energy network will be ready by 2035? Remember, it's tomorrow.
Yeah, good question. All of the predictions about a world which lines up to the Paris Agreement, and we want that, we want the world to line up and achieve the Paris Agreement, show that the energy network needs to evolve significantly. And I think what we're doing today is we're putting a stake in the ground and making it very clear that the aviation industry needs to also be powered by renewable energy. So in terms of planning, in terms of ecosystem development, which needs to take place over the next few years, what we need to do is take into account aviation's needs as part of that process.
Good. So again, here's another question for you. What are the issues and difficulties you've identified that you'll have to tackle in the realization of this project?
One of the really exciting things about this zero-emission aircraft is that it's got all of the technology and aircraft aspects which we've heard today, but it's much larger than that. As we've touched on, it's about a whole ecosystem, an energy ecosystem, an aviation ecosystem, which needs to change. So in terms of partnering, in terms of working across subjects which, as an industry, we maybe haven't had to deal with in the past, I think this is going to be a really exciting opportunity and challenge for us over the next years.
Okay. Grazie. You've been working on so many other technologies before what we're talking about today, including EFAN-X. Will any of that be useful as we move forward?
Absolutely. As I mentioned during the introduction, there is no silver bullet in our industry when it comes to decarbonizing aviation. Indeed, we need to work concurrently and coherently on multiple pathways, and that includes absolutely harnessing on our learnings, on our experiments and demonstrators when it comes to electrification, for instance. And we've been experimenting in that sense since decades with the CRE, the EFAN, the EFAN-X, Vahana, City AIRBUS. All our learnings on these demonstrators will flow seamlessly, of course, into any new consideration, considering hydrogen as a key component of a hybrid system.
Good. Jean-Brice, 2 questions in one in this one. You've revealed 3 concept planes. Which one would come first? And secondly, what kind of engines would you have on the blended wing body?
It's difficult to say which one would come first, because in fact there is no, I think you may have understood that there is no product, no exact product range behind these concepts. These are 3 different aircraft architectures. And naturally some aim at smaller or larger aircraft, but it's very early to predict which ones will be the winner of the game. So I think we need to buy 3 to 5 years in order for us to have matured our technologies, to have done the homework on those concepts, and to be in a position to say, okay, this is the one we're going to launch.
Okay, Grazia. Will Airbus be partnering with other manufacturers, airlines?
Well, for sure, the challenge of decarbonizing aviation is such that we by no means intend doing this on our own. So indeed, we are going to be reinforcing partnerships across the whole sector, across the industry, considering, of course, the research institutes, our customers. We have already several projects ongoing when we onboard other key stakeholders, and we will continue doing so until being able to deliver to our bold commitments.
Thank you. Glenn, okay, we go. 2 in 1. How is zero emissions flight possible? Especially, how can hydrogen be considered zero emission?
Hydrogen can be considered zero emissions because it's created from renewable energy, and we target making sure that there are, let's say, no non-CO2 effects when we use that CO2 on board the when we use that hydrogen on board the aircraft. It's not all resolved in terms of the solution and the details. We have a roadmap mapped out, which Grazia has spoken about earlier, in terms of some of the demonstration, testing, and technology aspects which we need to secure, put in place in order to secure our ambition for zero emission. But very clearly, we see hydrogen has the potential, has some work to do, but is really the most promising vector to deliver ultimately zero emission flight.
Good. Okay, who wants to answer this one? Would this work on helicopters?
Well, I've been the head of engineering of Airbus helicopters in my previous job, so I think I could take it for helicopters. Yes, hydrogen is a solution. I think Grazia said it quite eloquently. It's a solution that transforms mobility. So it's a solution for cars, for trucks, for trains. And in aviation, it's a solution for different segments. We already fly with hydrogen on rockets, on Ariane, and on satellites. So definitely, without going into too easy comparisons, helicopters can be flown with hydrogen. And I would even say that this may happen earlier.
Correct. So just to follow up on what you said earlier, with the research you've done already, so electrification it's still there. You're looking at many things there as well.
Absolutely, and as I mentioned earlier on, one of the configurations we're looking into is having a modified gas turbine. So with the technology developments needed at gas turbine level, with, for instance, new injection principles, new combustion chambers, where we will have an embedded electric motor. Powered by fuel cells. So the electrification component is by all means still there, and that's where the key learnings we have gained through our experimentation of electric flight will be of capital importance.
Glenn, it's all very well saying to the outside world, join us, we need you. You can't make them, or can you?
No, we're not forcing anybody, but I think this is an incredible ambition. We're talking about delivering zero emission flight to society. We believe that aviation as a connecting ecosystem is extremely important, and now we need to get rid of the climate impact. This is something which we're very clear about targeting, and this is something which we already see an ecosystem extremely excited to help us deliver.
Okay. From the passenger experience, what does this mean when we look at those concept planes?
For the passengers, it shouldn't mean a lot. It means being excited by flying with no climate impact. That's the, let's say, the heart of the passenger. But seen by the passenger themselves, at least in 2 out of the 3 concept planes, it wouldn't change much. On the third one, it's very exciting to see how we can modify the passenger, the cabin arrangement on the flying wing. But that's, let's say, a side topic to the development of hydrogen on board the aircraft.
Grazie. As we say, we can do this within 15 years. None of us are denying this is going to be difficult. It's not going to be easy. Why are you so confident as a group of you?
Of course, it's not going to be easy, but at Airbus, we don't like easy things. Let's not forget that we're only 50 years old and that we started from scratch into building the first wide-body aircraft to cross the ocean on 2 engines. So we've demonstrated it in the past, and we look forward to demonstrating it in the future.
Okay, here's another one for you, Grazia. How is recycling of aircraft going to work? I assume that most of these new aircraft will use composites, which, as we know, is not easy.
It's not easy, definitely not easy, but we are already spearheading several concepts on our manufacturing sites, typically in Stade, in Germany, where we have in place already treatments by means of pyrolysis to recycle composite waste and generate energy throughout it. So it's definitely promising concepts. We do not forget the industrial side of the story. We do not forget a life cycle management of our aircraft end to end.
Who wants to answer this one? How does Airbus view the prospects of battery-powered flight for smaller regional flights and planes?
I think batteries have their place in aviation, for sure. They are a very relevant technology for our industry. The question is, how big can we go with batteries? Where we're certain is that they can power definitely smaller applications, urban air mobility technologies. We don't believe that really it's a today relevant technology for large commercial aircraft, and we see hydrogen having much more potential.
All right, who wants to dare answer this one? How much has Airbus invested in this, and what would be the total investment?
None of us.
I can say maybe a few words. What we're talking about here is bringing a zero-emission aircraft to commercial entry into service. That is an ambition which will require billions in terms of investment. So what Airbus is putting behind this statement, this ambition, is the commitment that as we go through this cycle of technology investment, as the infrastructure gets developed, we're talking about spending the billions which will allow us to deliver a zero-emission aircraft.
Fantastic.
And if I may,
yeah.
It's also important to say that as we further develop technology harnessing on hydrogen, we will lower the entry barriers into this technologies also for other industries, entering therefore into a virtuous circle by means of which the cost of hydrogen, of sustainably produced hydrogen, will gradually decrease, and infrastructure will just be following step by step.
Great. Thank you so much for all your questions out there. They've been really helpful. And thanks very much to our panel for answering them. They weren't all that easy. I want to say thank you to all your teams who helped prepare this live cast, and also to the technical teams here in the studio here in Toulouse who helped put this all together. This live cast will be available to download if you missed the beginning in a few minutes' time. And we have a video news release already available with starring Glenn, and we have the animations as well, those video animations of those concept planes that you can download now to use for broadcasters and for video websites. You just a couple of seconds to say, obviously this is challenging, but we're very ambitious. We will update you in the weeks and months ahead as we pursue this quite amazing project. So, happy Zero Emissions Day, and thanks so much for joining us, and stay tuned.
Thank you.
Thank you.